My name is Keshwani. It's Keshwani. Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 162, and today is our lesson number 77. Problem number 74 is what we're going to do right now. It says a gym class. It's important that you turn to the page and read the problem to yourself. A gym class can be divided into 8 teams with equal number of players on each team. So there are a number of people in a gym class and it can be divided into 8 equal parts or 12 equal parts. The question simply is, what is the lowest possible number of students in the class? Which boils down to the same as this question that you see on the blackboard. We have an n, which is the number of students in the class. N can be divided into 8 parts or 12 parts. What is the lowest possible value of n? Which is a very roundabout way of simply asking you what is the lowest common multiplier. What is the lowest common multiplier? The lowest common multiplier, generally known as LCM, of 8 and 12 is what we are looking for. And the quickest way of finding the lowest common multiplier of a number is to go like this. Set them up, 8 and 12. And if you had more, if you had 3, 4, 5, whatever it is, you put them there, keep putting commas, and you start dividing by the lowest prime number that you can find. The lowest prime number is 2. 2 goes into both of them here, so that becomes 4 and 6. We can go one more round with 2, so it becomes 2 and 3, and that's it. So the lowest common multiplier of 8 and 12 equals what you see here. 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. That's it, that's your answer. So 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. 24 is the lowest number that you can have, which can be divided into 12 equal parts of each team will having two people in the team, or we can divide the 12 into 8 equal parts and each team will have 3 people in it. That's all. Very simple. Let's look at the next one. Number 75. Let's say we are done with this one. In number 75, we have a triangle ABC, which we are told is equilateral. And we are told that the point P is equidistant from its vertices A, B and C. Then we're going to pick up the triangle, and the triangle is rotated. It is rotated clockwise at point P. The question simply is, what is the minimum degree the triangle must be rotated? What is the minimum degrees the triangle must be rotated so that B ends up where A is. Now, so we're going to draw the triangle, an equilateral triangle, but because we are talking about a triangle being rotated, we're going to pick up our triangle, we're going to rotate it clockwise, and wherever the point A is, the question is how much we have to rotate so that B ends up where the A is. It will be much easier for us to see the entire process in terms of degrees if we put a circle around it, which is what I'm going to do here. So here's our circle, and in the circle we're going to put an equilateral triangle as best as we can. So there is a center. The center is what they're calling point P. So let's draw an equilateral triangle. and it is ABC. A, B, C. The question is, what is the minimum degree the triangle must be rotated so that point B ends up where point C is? Now it's very easy to see, you see? From B to C, let me put it here. If we were to go from B to C, here's the solution. B to C is a third of a circle. Is a third of a circle. As you can see, from here to here is a third, because the entire circle has been cut into 3 parts. This is 1/3 of the circle. This is 1/3 of the circle. This is another third of the circle. This is another third of the circle. Because of the fact that these sides are equal to each other. It's an equilateral triangle. So if you were to go from B to C, a B to C is a third of a circle. Similarly, once we arrive at C, so we have our point B, we arrive at C, from C to A is another third. It's another third. Therefore, if we want to go B to A, going clockwise is important, because if we were to go anti-clockwise, it will be only a third of a circle if we were to go anti-clockwise, but we are told that we have to go clockwise. And if you don't understand what I mean by anti-clockwise, counterclockwise for the Americans. They call it counterclockwise as opposed to anti-clockwise. So we're not going anti-clockwise, we're going clockwise. If we're going clockwise, it's going to third of a circle, another third of a circle. I think I'm making too much fuss about nothing. So if we want to go from B to A, we're going to end up traveling. We are going to end up traveling 2/3 of the circle. And of course we know, let's continue on the top here. We know that a third of the circle is a third of 360 degrees, which is 120. Therefore, 2/3 of the circle is going to be 120 times 2, or 240 degrees. That's the minimum. The reason why they use the word minimum is because, of course, you could go around 10 times and then stop here. That would be silly. The least distance that you can travel going clockwise is to go from B to C, which is 120 degrees, and then go from C to A, which is another 120 degrees. So that's it. So you're going to end up traveling 240 degrees. I have the feeling that I probably explained way too much than I needed to be. Probably it's a simple problem for most people. All you have to understand here is a simple concept that the entire circle is made up of 360 degrees. You're going to go a third of a circle and then another third of a circle. Therefore, 2/3 is 240. That's it. That's it. We're done with it. You want to do one more? Let's do one more. Might as well. Let's do 76. Because it's the last problem on the page, so we can get done with this page. That's it. We're done here. In 76, they tell us that at least 2/3 have to vote in favor. The total number of people that we have are 40. The question is, what is the most who can vote against? So there is some resolution they need to pass, and in order for that resolution to pass, it has to have 2/3 majority, and at least 2/3 of the 40 members of a committee must vote in favor of a resolution for it to pass, you see. And therefore, the question simply is, what is the largest number of people who can vote against it and have the resolution still pass? Well, let's find out. 2/3 is what we need. 2/3 of 40 what we need is 2/3 of means multiply 2/3 of 40. Let's find out, shall we? 40 divided by 3, how many 3s in a 4? 4 has 1 3s. The remaining one goes and joins this guy, becomes 10. If you divide 10 by 3, you end up with 3 and a third. So it's 13 and a third. Let me do it a little bit lower so we can see it better. Two-thirds of 40. Let's divide 40 by 3. How many 3s in a 4? 4 has 1 3. The remaining one goes and joins a 0, becomes 10. How many 3s in a 10? 10 has 3 3s and a third. Times 2. So this 3 is gone. 2 times 13 and 1/3, which is same as 13 and 2/3. But obviously we can't have a two-third of a person voting in favor, because we need to have 2/3 in favor. We can't have a 2/3 of a person voting in favor. Therefore the minimum that we need to vote in favor is going to be 14. This is not right. 2/3, 13 and 2/3. Where did 13 and 2/3 come from? 2 times 13 and 1/3 is not 13 and 2/3, it's 26 and 2/3. 26 and 2/3. 2 times 13 is 26, and 2 times a third is 2/3. 2 times 13 is 26. 2 times 13 is 26, and 2 times a third is 2/3. So the minimum that we can have voting in favor of the resolution is 27 people, because we can't have 2/3 of a person. Therefore, the most who can vote against is the total number of people that we had minus the 27, which is 13. That's it. 13 is the most who can vote against it and have the resolution passed, not 14. So that's answer choice E. And that's it. We're done with that one. Tomorrow we'll start the next page, okay? Bye now.